Welcome to this video tutorial where we'll take your map from being a static image like this more to something like this that you can scroll around, zoom in and move about, whilst also adding this dynamic pin for the UR here. You'll notice that as it zooms in, the pointer to say you are here also stays in the same position and scales accordingly. So once you open up your project, you should have the main file open. We won't need to make any adjustments to this because all of the logic will program will be in this map.py file, or the file name that you've called your map screen. The first thing I'm going to do is make some variables that will track how big the map's scaled, where it's positioned on the screen, and the image. So underneath here where it says initialize variables, I'm going to initialize 4 more. First of all, self.mapScale. Remember, we have to put self because this is object-oriented programming, so we need to refer to the instance of the class, not the entire class. Then we're going to do map offset for the x-axis, the map offset for the y-axis, and then the map image, which we'll currently set to none. We're also going to need a couple more variables to help the app track as it's being dragged. So we're going to make a variable called drag start x and then drag start y. We're also now going to tell the computer a definitive location for where the pointer on the map that says you are here should go. So I'm just going to call that you are here. I'm going to say it's 800 across and 600 down on the image of the map. And then we just need to move this frame down here because this will be part of our widgets to below the variables. So it should start to look a little something like this. You'll see that you should have already put in your zoom in and zoom out buttons here. And we have two definitions, so on zoom in click and on zoom out click. These we will come to program later. I'm going to start by taking my whole map image, which is this bit here, and commenting that out. You can do that in VS Code by pressing Ctrl and /. I'm leaving it commented out in case my code breaks, and then it's a good starting point to come back to. The first thing that I'm going to do is open the map image. We're using a different library this time. We'll be using the PIL image open library. So image.open, and then just like before, I'll put the path to my map image. So asset/map.png. Then I'm going to get the width, declare the width, the height, and that will be equal to the image size. Remember that resolution is just height times the width. Then with the map scale, I'm setting mine to 160 over the self map image width, because that's how wide it is on my screen. It might be different for you. You'll see mine was actually 1660, but 1650 is close enough. And then next, instead of just putting an image in there, we're going to create a canvas. So we're going to say map canvas equals a TK canvas. Remember, TK is a library that makes our graphical user interface. We're going to make a frame. We're going to give it the width and the height that we had in our photo before. So this might vary for you. So mine's 1650 by 350. And then I'm going to give it a background color. Mine's just going to be grey, so 2D, 2D, 2D. I'm just going to put highlight thickness as 0 for now. And then the fun thing is you can actually change the cursor that shows up when you go over the map. So for me, my cursor will be hand 2. Don't forget to add your commas at the end of these lines, or you might start running into issues. Then outside of the bracket, we're going to place the canvas in the graphical user interface. Again, these are all dimensions that you can work with. to make sure that it fits your application correctly. So again, you'll see here 1660 and 1020 is exactly the same that I had before for my normal map image. So you've successfully created the canvas with the picture in it. However, a couple of things we need to do before this section where we actually build the GUI comes to an end. We need to bind the events that allow the user to drag and manipulate the map to functions. The way we do this is we call the variable, so the map canvas here, we say dot bind, and then for the mouse press we're going to put square brackets button press -1, and then we're going to bind that to the event self.onMap drag start. You can obviously rename these so that it's more efficient in your code and you understand them better, but for the purposes of this tutorial, this works the best. Then we also need to bind the actual motion of the mouse and how the laser tracker on the mouse moves. For this one, we'll bind the event b1-motion, and we'll bind that to the function self.onMap drag move. And then finally, to make sure that the map shows up on the screen, we need to do self.drawMap. Now that we've created the map in the create widgets function, we can now go down to the event handlers. Remember that event handlers are just functions or procedures. They're subprograms, they're pieces of code that tell the code what to do if they are called on. The first one that I'm going to do by making a few spaces here is the draw map. So I'm going to say def draw map, and then I'm going to pass through just itself. The first thing we need to do is clear the map. If it keeps drawing the map but not clearing what came before it, you'll end up with a bit of a mess on your screen. So we'll do self.mapCanvas and delete all. Now, it's possible that when we redraw the map, there might be a new width, there might be a new height, it might have scaled differently. So we need to work out the new width. And we're also going to set a maximum limit between 1 and then the actual map image width times the scale. We're also going to repeat this for the height. So what this does is make sure that you can't make the image any bigger than the natural scale of the image. We're now going to work out the resized image size. So we'll make a variable called resized. Remember that these are local variables. They exist inside a function, or in the case of OOP, an event handler. Because of this, we don't need to use the self to declare it's of the instance. However, for external global variables, we do. So when we're calling the map image variable, we need to put self before it. We're then going to resize it with the new width and the new height that we just worked out. And then we're going to use this library here, image.lengthsoz. Next, we're going to do the map photo. And then we're going to use the image.tk library. And then we're going to pass through the parameter of resized. Next, we're going to actually create the image on the canvas. You'll see that's a built-in function of the library. We'll then pass through our offset of the X and offset of the Y so that the computer knows where to position the map inside the canvas. Don't forget your commas again. And there we go. We're also going to anchor this by putting anchor equals NW in single commas. Single speech marks. And then we'll say that the image, so the actual image it needs to draw, will be the map photo. Then finally, I'm just going to put in drawing the pin. We haven't made this function yet, but I will call it draw pin. What this will do is call another event handler or another function to then draw the "you are here" pin on there. The next function we're going to make is the one that will be binded when a mouse click is detected on the image. So it's that one we named before. It'll be def on map drag, and it's the start one. We'll pass through two parameters: itself, obviously the instance of the class, and the event that actually happened. Then we will call our two variables drag start x. We'll set that to event.x so that Python can pass through that data, and then self.drag start y, and we'll attach that, as you may have guessed, to event.y. That's it for that function. We're now going to move on to the other event binded function, which is on map drag move. Again, we'll pass through the instance of the class and the event that actually happens. This one will get a bit more complicated. So dx, so delta x, will equal event.x minus the self.drag start x. This is working out the difference in the movement. So dy delta y will equal event y minus self.drag start y. Then drag start x will equal event x, and then self.drag start y will equal event y. The reason for this is that the next time we come to move the map, we want it to move from the new updated position and not suddenly jump back to its starting position and then move. Now we'll update the map offset x by adding delta x to it, and we'll update the map offset y by adding delta y to it. We're then going to draw the map again. That is the end of the onMap drag move function. Now we're going to want to program something for the actual map zoom. So I'm going to call this map zoom. We're going to pass through the instance of the class, a factor, a pivot for x, and a pivot for y. Because remember, when you zoom, it can't just zoom from the center, it has to zoom from wherever the user has centered it. So, first of all, we'll work out the new scale by making a variable, and we'll have the map scale, and we'll multiply it by the factor. Whether you've zoomed in or out, this will apply correctly. We'll also maximize how big or small you can make the photo, as mentioned before, by using the max function. I'm going to set mine to 0.3, then min 5.0, new scale. First, we're going to work out the pivots by doing image pivot x equals pivot cx minus self.map offset x, and then we're going to divide that by the map scale. We're going to repeat this again for image pivot y. I'm just going to copy and paste this line here, and then change x to y. And then we're going to work out the offset. So self.map offset underscore x equals that pivot cx we used minus the image pivot of x, and multiply that by the new scale. And again, repeat this for y. So the offset of y is pivot cy minus image pivot of y, and multiply that by the new scale. Just scrolling up here, we're then going to make the map scale variable equal the new scale that we've just worked out. Then finally, we're going to draw the map again. Now you can see I've got two event handler's already written here with comments saying to do, implement your logic here. I'm going to delete those comments, delete the pass, because once you fill in a function, you no longer need it to say pass. It becomes inefficient to do so. Pass just means that it won't cause an error if you have a blank function. So on zoom in click, we're going to set the map width to 1650, map height to 350. You'll notice I'm using caps because these are constants. And then we're going to do map zoom, which is that function that we just made. I'm going to say 1.3 and then map width over 2 and map height over 2. I'm then going to copy and paste this code to the zoom out one. And then I'm going to instead do 1 over 1.3. This is now our zoom working. Ultimately, the only thing we have left to do is do this draw pin bit. For now, I'm just going to comment that out. Coming back to drawing that pin, there are a few things that we need to give it. We need to define it first of all, and we need to define it before the draw map, otherwise it won't be able to call on it. So def draw pin, and then we're going to pass through itself, and then we're going to use those constants we made before again. So the map width and the map height. Remember, local variables, we don't need to use self dot. Then we're going to do image x and image y and set them to self. You are here, which remember we made all the way at the start up here. I just used 800 and 600 as an example. Then we're going to say cx equals image x multiplied by self.mapScale and add the map offset of x. If we don't add the offset, remember the pin won't move with the picture, it'll stay stuck to its location on the screen. Then we're going to repeat this for the y coordinate of the pin. And then we're just going to do a little bit of safeguarding, making sure that it doesn't go off the screen. So if not, 0 equals cx, which is less than or equal to map width, and make sure it's the same for cy. 0 is less than or equal to cy, and map height is greater than or equal to cy. I'm just going to put return if that is the case, and don't forget the colon. Next, I'm going to set the radius of mine to 20 pixels. I'm going to say self.mapCanvas and then create oval. We're then going to do cx minus the radius plus 4 and cy minus radius plus 4. Then we're going to do cx plus radius plus 4, and then cy plus radius plus 4. Then we're going to give it a fill color. I'm going to use the same color that I used before, 2D, 2D, 2D. Then comma, and then an outline, and I'm going to leave that blank for now. Next, outside my bracket, I'm going to do self.mapCanvas.create another oval. This time, I'm going to do cx minus r, cy minus r, cx plus r, and cy plus r. I'm then going to colour this in with a white colour, so I will use E63946, and then I will give this one an outline of white and a width of 4. We're then going to create another oval because we want this kind of embedded oval within an oval. Then we're going to do cx minus 5, cy minus 5, cx plus 5, and cy plus 5. We're going to fill this in white and have no outline again. Finally, we need to create the text that says you are here. So we'll call on the map canvas instance again, and then we'll say create text. We'll place it at cx, cy minus r minus 8. We'll tell it the text is you are here. We'll fill the text in color white, although this might not work best on your map. We define the font as Arial. I'm going to make mine size 11, and I'm also going to make it bold. And then we're going to give it an anchor as S. Save that, and then go to your main file, run it. When you click on map, it gives us an error. Let me just look at this. Oh yeah, so it's just because I wrote that as a function instead of saying equals. So I'm just going to save that again. Make sure you put you are here equals that, otherwise it will just try to call a function that doesn't exist. Run that again. And then when we click map, here we go. So we have the canvas, we have the zoom in and out. We're just not getting the image right now. Let's see if Visual Studio Code has any errors. Here we go, image TK is not defined. Did you mean image TK? I can see that I've accidentally capitalized that K right there instead of making it a lowercase k. So just control and clicking on the line number in the terminal helps take you to it. Save that, run our main again. Click map, and still no image. So now let's see what the error is. And again, I can see here in the terminal, I've missed a square bracket here. So button press, searching the wrong file. So button press, and you can see I've just missed that square bracket there. Now, this time we should go to our main and run it, and it should work this time. So click on our map, and there we go, our picture's loaded. Bear in mind this is using the CPU, not the GPU, so it will struggle once you start zooming in and moving it about. It will lag quite a bit, quite like mine is doing. But I'm also noticing that we don't have a pin. So let's just look, and it just says invalid color name. So I'm going to go to last local error in my code, and I can already see I've accidentally put an extra hashtag there. So again, just run that code, press map, and there you go. You can see our you are here is there. And that's how you now make a scalable map with a fixed you are here pin. Remember, you can duplicate this to show where stores are or fire exits. And that's your scalable map working.